Hello all, welcome to the new video. In this video we'll see what is reverse saturation current and what is the significance of it. So before going further, let us understand the working of BJT, because that is very important for us to understand the working of BJT in order to understand what is reverse saturation current. So here is a NPN transistor, that is BJT, NPN transistor. So this NPN transistor is in the active mode of operation. Okay, there are three modes of operation. The BJT has three modes of operation. They are cut off, active and saturation. So what happens in active mode is, so this is, what is this? Emitter, base, collector. Okay, so in active mode of operation, EB junction is forward biased. As you can see, E is connected to the positive terminal of the battery, and the emitter, which is N type, is connected to the negative terminal of the battery. So this is EB junction is forward biased. So and then collector base is reverse biased. So any BJT which is biased in this fashion is working in active mode of operation. So this BJT is working in the active mode of operation. So if we understand what happens in active mode of operation, we'll get to know what is the reverse saturation current. So we'll see the working of this transistor now. Okay, so this BJT is working in active mode of operation. As you know, BJT stands for bipolar junction transistor. It means, what is the meaning of bipolar? That means both electrons and holes constitute the current. Okay, means the current is conducted by both electrons and holes in BJT. So this is an active mode of operation. So as you can see, this EB junction is forward biased. Just concentrate on this part. Okay, so what happens? This EB junction is forward biased. It causes current to flow across this junction. This current consists of two parts. Okay, the first one is electrons are injected from emitter to base. This is electrons are injected from emitter to base, and also the holes are injected from base to emitter. I'll denote holes by H. Okay, H plus. So these are the two types of current. This electrons will flow from an emitter to base junction, because N type is full of electrons, and whereas P is of holes, because it is P type. P type dopant will be having more number of holes. So what happens? These are injected from emitter to base as well as base to collector. But what is, due to the heavy doping of the emitter, more electrons will reach the base from the emitter than the holes, than what the number of holes reach the emitter from the base. Okay, this is heavily doped. That means more electrons will reach the base from the emitter than the number of holes which reach the emitter. So electron current is dominant. That is what I want to say in this context. Electron current is dominant. Okay, so since the base width is very small, very few of the injected electrons are lost in the recombination in the base region. So as you can see, this is full of holes. Once these electrons reach from emitter to base, some of the electrons will recombine with holes. That is, basically there is a gap here, so these electrons will go and sit here. That is nothing but recombination. So this base width is very small, so very few electrons will recombine. Rest of them will cross this junction and reach the collector. Okay, so at this juncture we will define a special What is the definition called as alpha? Okay, so this is the ratio of collector current to that of emitter current. So typically this value is of 0.98 or 0.99. Some of the recent VJTs also have reached up to the value of 0.995. So what it means is more than value of alpha, that is the maximum value of alpha is 1, because what is emitter current will go to collector current. So that is the maximum value of 1. If there is 1 milliampere of emitter current, all of it will flow through the collector, then alpha will be 1. But however, in our case, some of the current, electrons are lost in the recombination with holes in this junction, P junction. Okay, hence our alpha is less than 1 and it is very close to 1, is 2.98. So what I wanted to say is large number of electrons diffuse towards the collector. Okay, so the collector will collect most of the electrons injected by the uh, emitter. So this is the definition. Alpha is nothing but ratio of IC upon IE. If alpha is 1, both IC is equal to IE. So the number of electrons which reach from emitter to collector, okay, say now 50 electrons have jumped from emitter to collector, have traveled from emitter through base to collector, 50 electrons, for VB is equal to 0.3 volt. So if VB is increased to 0.7 volt, the number of electrons will rise exponentially. Say for 0.7 volts, 250 electrons will reach from emitter to collector. So what I want to say is the current in the BJT increases exponentially as PBE increases. Okay, so that is one case. So we have studied about this IC and IE. So most of the emitter current will flow through the base to the collector. But there is also another component called as base current IB. So this base current also has got two components. So base is nothing but p-type. This is a p-type dopant. It means holes are the majority carriers. But few holes, that is these holes, have lost due to the recombination with the electrons. What happened? This electron went and sat here. So this is gone. So a few more holes which are left in this p-type, what they have jumped through this junction and have reached the emitter. So this constitutes the base current. Okay. Whereas the collector current is nothing but this. It is defined by this equation. So it can be understood from this discussion what is going on is that if the forward bias across the emitter base junction is increased, more electrons will leave from the emitter and consequently more current results in base and collector. However, increase in this reverse bias, say this VBC, if you increase any VBC to more value, suppose say it is 1.01 volt, if you increase it to 1.5 volts, nothing much happens in the terms of current in the BJT. So based on this fact, and we can apply the Kirchhoff law on this node. As you can see, these are all nodes. So IE is equal to, I can define that IE is equal to IB plus IC. What happens? Most of the electrons which flow from emitter, few are lost in this base, that is the base current. This base current, I also talked about how volts travel to emitter. So this also constitutes the base current. But majority of this current IE is nothing but IC will take most of the IE value. So this is the Kirchhoff's law. So I have explained few things now till now. I will repeat it again for the better clarification. So let me tell you, when EB junction is forward biased, this is N type, okay? It has majority carriers as electrons. So these electrons, they will move towards the base junction. So this base is P type. It means the majority carriers in this P type are holes. But it is the width is very small. So it means lesser number of holes. So what happens out of these many electrons, say around 150, around 10 electrons will combine with holes. Remaining 140 electrons will travel to the collector. Okay. So this is the so with that explanation we defined IC as alpha times IE. It means alpha is around 0.98 and remaining electrons recombined with electrons. Also the emitter current can be is constituted of two things, okay? One is IEN and IEP. So what is this IEN and IEP? So IEN is that part of the current which is due to electrons flowing from N to P. So that is this direction. This red arrow what I have marked is IEN. I have also said that some holes will get combined with holes. However, there are still more holes which will travel to the emitter. I can say the H plus. This yellow mark is called as IEP. Since this is a BJT bipolar junction transistor, that current is due to both electrons and holes. Okay. So now we are done with this part and also we are done with this part. Okay. However, the actual IC equation is given as IC is equal to alpha times IE plus ICBO. So the whole video main intention is to find out what is this ICBO. So now we are familiar with the operation. We can understand what is ICBO. ICBO stands for collector to base with emitter open. Okay. So we are just concerned with this part now. This under this CB junction, what happens? This is reverse biased. This is nothing but a diode is in reverse bias. Okay. So if this diode is in reverse bias, forward direction no current flows. However, in the reverse direction there will be some current flow. That is nothing but ICBO. Okay, in this case, because we in transistor only we will define what is collector base and all. In terms of diode, this is nothing but IS. Okay. So what happens? As you can see here, this is P type. It has more holes. PP. It consists more number of holes. Okay, and this is electrons. So when we sandwich these two while making the transistor, what happens? Due to diffusion, some of the holes they will reach here, and some of the electrons will travel from N side to P side till there is a potential developed across this junction. This is the junction, okay? So just as the diode operation. So there is a electric field over here. So what happens? This N side, this is the N type. In that majority carriers are electron, minority will be holes. Okay. So these are minority called holes. So whenever the temperature is increased, what happens? This will gain sufficient energy and they will move towards the junction. So this electric field, what it will do? It will sweep these holes from N side towards the base. And also same case in the P side there will be some majority charge carriers are holes and minority charge carriers are electrons. There will be some electrons. What they'll do? They will carry. They'll be having enough energy due to thermal agitation. They will reach this junction. and since there is electric field, this electric field will sweep these electrons into the collector. I will use this. Okay, so this is the this two directions. As you can see, some of the holes in the collector base. This is the collector. Some of the electrons in the base are swept to the collector, and some of the holes in the collector are swept up to the base. So this also carry some current. That current is called ICDU. It is the sum of these two currents. That is due to electrons from base to collector and due to holes from collector to base. Remember that base is P type, collector is N type. So this is the reverse saturation current. So reverse saturation current ICDO depends only on temperature. For a given temperature it is constant. For a material, for a given material, for silicon or germanium, ICDO is constant. If temperature is increased, then this ICDO will increase. So that is not in our scope to derive the equation for ICDO and all. Just understand that these are the current, leakage current, which is possible only due to the migration of minority carriers from across the junction. So remember that we are dealing with NPN BJT transistor. So we define two things. The total emitter current is equal to sum of base current plus collector current. This is equation 1. And also we have defined that IC, that is collector current, is not only a part of emitter current, but also there exists a current called as reverse saturation current ICDO, which exists in irrespective of if emitter is open or not. This is due to the only CB junction. So this current is due to the migration of minority carriers across the junction, and this depends only upon temperature, and it is constant for a given temperature for a given material, that is for silicon or germanium. So using these two equations, we'll substitute in here. In the case of IC, in equation 1, we'll replace it alpha E plus ICBO. So we can write IE as IB plus ICBO upon 1 minus alpha. So this we can split for this IB upon 1 minus alpha plus ICBO upon 1 minus alpha. There is another equation which will relate beta to alpha, that is beta is equal to 1 upon alpha upon 1 minus alpha. So using this equation over here, we can write this IE as IE is equal to beta plus 1 IB plus beta plus 1 ICBO. Okay, so this is the equation for emitter current IE. So in order to get IC, just subtract IB from equation 1. Okay, it means subtract IB whole. So this beta plus 1 beta into IB plus IB. Bring this IB over here, we'll get collector current IC. That is nothing but beta IB plus beta plus 1 ICBO. So as you can see, this leakage current has been amplified by beta plus 1. Okay, so what happened? There are three terminals. So there is a leakage current ICBO here. So once it will reach here, it will get amplified and it will move towards the emitter. So this is nothing but beta plus 1 into ICBO, just like this base current. Okay, this is the direction of actual current. Okay, what I have drawing here. The electrons, however, move in this direction. So that is another story altogether. The conventional current is always opposite to that of the flow of electron current. What I have explained is in terms of electron current. However, you can remember that this ICBO, the collector current which we measure, is not only beta times IB, it also has this component there. So it largely depends upon temperature, this part. So IC also depends upon temperature for this BJT. Okay, so that's all for this video. Uh, in a few more videos, or after some more days, we will derive the equation for this reverse saturation current. So like how it will depend upon temperature. Approximately what happens, this reverse saturation current, it will double for every 10-degree rise in temperature. So we can see how it is possible and all. So that's all for this video. In the coming videos, we'll deal about stability of the BJT. As you can see, this collector current. So as you can see, this is the BJT characteristics. You choose the operating point. Okay, this is IC1 VCEO. The operating point which you fix, it should be stable enough. It shouldn't move. But what happens, since this current is largely dependent upon temperature, this operating point, it may move here, it may go into cutoff and all. So at that time, your circuit will not work according to the your design. That is, if you think it will work in that way, it will not work because of this temperature dependency. So we have to eliminate this dependency. So that is what stability is all about. We will deal about that. So this was the prerequisite for that. Hence I have dealt with this lecture. Okay, thanks for watching the video. Um, I'm sure that many have a lot of doubts regarding this video. Please use the comment section, and also you'll appreciate the value of MOSFET once you read BJT, because BJT is a lot of mess. But it is interesting. We have evolved across over the years, and if any doubts, please use the comment section, and please don't forget to subscribe to our channel. Thank you.